All right, so we are going to do two sections from chapter 10. And chapter 10 is really about conic sections. And what that means is if you take a cone, okay? So imagine like an ice cream cone. And you were to imagine like slicing it with like a blade, okay? If I were to slice this across with a blade, the cross section, if I cut that in half, the cross section would be like a circle. Okay, you guys see that? So a circle is like a shape that we get from doing that, like cutting a 3D shape in that way. But if I cut my cone on an angle like this way, if I cut it this way with my blade, the shape you get is something called an ellipse. Okay. So if you go straight across, you get a circle. And if you slant it, you get something called an ellipse, which is just like an oval. So that's kind of where this stuff is coming from. And then there's other shapes that you can get depending on how you cut it. We're going to just focus on these two. Okay. And I just did that so you have a visual of where this is kind of coming from, but we're not really going to talk about that too much more. Okay. So let's do some definitions. So we're going to start with 10.2 and then I'm going to circle back. Ha ha ha. You don't understand that pun yet, but 10.1 is about circles. So I'll come back to it once we talk a little bit about ellipses. Oh, the corny math jokes. All right. So here's a definition. An ellipse is a stretched or enlarged circle. Okay, so it looks like typically the pictures that you're going to see, it'll look like this, or they can be horizontal, like stretched horizontally. Or you're going to see them stretched vertically. Okay, so horizontally stretched and vertically stretched. Now, these do have a standard equation. So there is a standard form of an ellipse. Let's do it in blue. And it goes like this. So I take x minus h squared is divided by a squared plus y minus k squared over b squared is equal to 1. Okay. So to be clear, an ellipse is two-dimensional. It's two-dimensional. We typically put it on the XY plane. I'm just saying when I put this picture up here, you can see how we cut a three-dimensional object to get it. That's all I was trying to say up there. But here's the formula for an ellipse. Now, HK is not new to you guys. How has HK been used for us before? Does anybody remember?
Vertex.
It's the vertex. Now, in ellipse talk though, in the terminology for ellipse, it's called the center. Okay, so this is where h comma k is the center of the ellipse. Okay, so in both of these, this would be H comma K on a grid, okay? So the center here. So if, let's switch back. If H equals 0 and K equals 0, then the ellipse is centered at the origin. Hmm. 0, comma 0. So let me just show you just a quick picture of that, like this, centered here. Okay, right in the middle. Okay, now A and B are also important. We gotta make sure we understand like what these little pieces are right here. Okay. A and B are the vertices of the ellipse. Okay, they're the vertices. So A tells you the number of units from the center the ellipse is stretched horizontally. From the center. Which is left, right. So in my picture up here, okay, this would be, this is A units, and then this would be A. So this distance is equal, you know, it's equidistant. So this point would be whatever A is, A comma 0, and this would be negative A comma 0, okay? I see in the chat that, Thomas, you're asking something about roses. Do you mean, oh, it was private, sorry. I think what you're talking about is something to do with polar coordinates. Is that what you're talking about? Which is not in this course. This is the most like shape stuff we're gonna do. Okay. All right. Now, number 2, let's talk about B. Oh, you learned when you did ellipses. It might be an ellipse that I'm not sure if it's reiterated or something like that. I can see it looking like a rose. But no, we're just going to talk about the basics. Okay. All right. So B is similar. B tells you the number of units from the center, the ellipse is stretched vertically. So up, down. So in this case, it would be 0B and 0 negative B. Okay. So in there, again, it's the same distance. Okay. I know my picture is the circle, the ellipse is not quite centered, but imagine that it is. And that's what you're talking about. Okay. So a lot of terminology with the formula. The formula tells you when it's in this format, it gives you the center and it gives you how far to go right and left and how far to go up and down, basically. Okay, so let's look at an example. Example 1. graph x squared over 4 plus y squared over 9 equal to 1. So here's an ellipse. Now, how do you know it's in the right format? The first thing you should notice is that there has to be a 1 on the right side. Has to be 1 on one side of the equal sign. Okay? You have to have it equal to 1. If it's not equal to 1, it's not in the correct format. Okay? So I just wanted to point that out. So let's look at, what is our center here? What do you guys think the center is? What would you guess? Anybody want to take a guess? Okay, Marian. Yes, it's 0, 0. Okay, oops. 0, 0. And how do you know? Because there's nothing being subtracted from x and y. Okay, realize that this is the same as x minus 0 squared over 4 plus y minus 0 squared over 9 equal to 1. Okay. All right, but it's kind of like silly to just write minus 0 in there. So just the x and the y by itself, it tells you that that's the center is 0, 0. Okay, we also get that the denominator, now remember this denominator is a squared. Okay, it is something squared and something squared. So a is the square root of 4. It's the number underneath the x term, which is 2. And b is the square root of 9, which is 3. So I know that a is 2 and b is 3. Okay. So what tends to be a little bit easier? I don't know. Can I get no, I don't want to do that. All right, let's I will get my axes here. So here is y, here is x, and so my center is right here, 0, 0. Okay. Yeah, so I know that this is the left right. Okay, so I'm going to go 1, 2 units, 1, 2 units. And those are vertices, okay? They're points on my ellipse. And they're the furthest right and left point. So that's why they're called vertices. And then for B, that's up and down. So 1, 2, 3, and then 1, 2, 3. So that's 3 and negative 3. Those are those vertices. And then once you have the center and the vertices, then you're going to draw your ellipse. And yes, this one is stretched vertically because it's longer vertically than it is wider. Okay, any questions? All right, let's do one like this. So example 2, x minus 1 squared over 9 plus, oops, I jumped, y plus 5 squared over, let's make this interesting. Let's do 25. Change my problem. Yeah, okay. So let's see, let me call on someone. How about Jack? What do you think the center is here? Are you there, Jack?
Yeah, I'm here.
What would you take a guess?
Would it be 1, -5?
Yes, very good. I didn't even have to tell you. Very good. So it operates the same way. Oh, turn your mic back off because I'm getting feedback here. Thanks, Jack. Sorry. All right, good answer. It works the same as like the parabola, because actually parabolas are conic sections too. I didn't go into that, but it's the same way. So it's the opposite of what you see in there. So minus is standard form, so you just pull off the 1, but +5 is really minus a -5. So you got to take out, it'll be a -5. Okay. Now a is the number underneath x, the x term. So that's going to be square root of 9, which is 3. And b is square root of 25, which is 5. All right. So let me get my axes down here. All right. I'm going to shrink it a little bit. And let me use some color here. So I have 1, I'm going to put points on here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2. Oops, I don't like those. 1, 2, 3, 4, 5, 6. It really does help to have a nice even grid with these. So, all right. So first you're going to do the center. So our center is 1, -5. So that's 1, 2, 3, 4 here. Now the thing is about the A and the B is you're counting away from the center. Okay. So I'm going to go left for A. This is left, right from the center. So that's 1, 2, 3. And then in the opposite directions, 1, 2, 3. Okay. So my center here is negative, or I'm sorry, 1, -5. And then if I go 3 right, this is 4, -5. And if I go 3 left, I'm at -2, -5. Okay. It's helpful to label those. Now for B, I'm going to go up, down from the center 5 units. So let me do this in orange. 1, 2, 3, 4, 5. Okay. And then 1, 2, 3, 4, 5, which I didn't even, this is 1, I'm sorry. This is the point, yeah, 1, 0. And this is the point 1, -10, right? So you can kind of see it should look pretty equal in both directions. All right, now let's see how good I can draw this. All right. And there we go. There's our ellipse. Now it does look more like a football there because I didn't do a good job, but you guys get the idea. These don't have to be perfect. They should be like rounded on the ends, but they do not have to be perfect. Okay. All right. So any questions so far? Seems pretty simple, but you know, things do sometimes take a turn. These don't get too much harder, but we will do a little bit more. No, it would just be a different, so if Cindy's asking, would it be no solution if it's equal to any other positive number than 1? No, we're going to see, just like most things, you can get it in the formula you need. So I'm giving them to you in like the perfect case scenario, right? Like the best case scenario, you're getting the formula already set up for you. But just like with parabolas, we had to learn to convert them to vertex form. There is some work to do sometimes to convert these to the standard form. Okay, so we'll get there. So here's another example. So say I have x minus 3 squared over 9 plus y squared over 9. And this is equal to 1. So this is an ellipse. Okay. Now, what is my center here? center? How about coral? What would you say the center is?
Is it positive 3, 0?
Yes, very good. So 3, 0. And then if you notice, look, the A and the B are the same. So A is square root of 9 is 3, and B is square root of 9, which is also 3. Okay. So let's look at this on the grid. My center is 3, 0. So 1, 2, 3. And then I have to go 3 units away in both directions. So let me just put these on here. 1, 2, 3, 1, 2, 3, 1, 2, 3. So here and here, and then up and down 3 units. Okay, so then I connect my vertices. I don't like this one. This is the point 6, 0. This is the point 3, 3. This is 3, negative 3. And this is 0, 0. Okay, what do you guys notice is special about this ellipse? There's something kind of special here. Oh. Ugh, keep making it worse. Yeah, it's circular, isn't it? Like, yeah, it looks like a circle. Good. Yes. So when A and B are the same, you get the same distance in every direction, right? This is 3 units away from the center. This is 3 units away. In fact, every point on this circle is going to be exactly 3 units away. That is the definition of a circle. So let me write that directly. So it's a circle with radius equal to 3. So another observation is A equals B. Okay, so let's do definition here. When a circle is a set of points in a plane, so in our case on this grid, okay, in a plane, that are a fixed distance yes, that's right. A square is a type of rectangle, but a rectangle isn't necessarily a square. A square is a special form of a rectangle. A circle is a special form of an ellipse. That's a good association. In a plane that are a fixed distance, r, which we call radius, from its center, that's possessive, so there's no apostrophe, from its center, h comma k. So if you want to look at, here's some standard forms of a circle. Okay, so how does this differ a little bit? We still have x minus h squared, but now what we typically, since a and b are the same, we usually just refer that to as the radius. And so this is y minus k squared over your radius squared equal to 1. Now, if I multiplied everything by r squared, if we cleared fractions, okay, you also get that x minus h squared plus y minus k squared is equal to r squared. So these are both often used because it's the same formula. Okay, it's the same thing, but you'll see stuff in this format. All right, so where am I at on time? Okay, we're doing good. Let's do some classifying. Classify each of the following as an ellipse or circle. All right, so I'm going to put the equation here and then classification. Here's A. So x minus 1 squared over 4 plus. Now, before I finish this, what I want you to do is let's do this in a participating kind of way, because I'm sure you guys are like snoozing on me, throwing a million definitions at you in formulas, okay? Well, not a million, but enough. So you can put it in the chat, or how about we want to do the thumbs up? Maybe that's easy because then you don't have to type. So it's up to you. If you want to type it, that's cool. If not, just give me a thumbs up if it's an ellipse. And how about, let's do this. Ellipse. Thumbs up. And a circle. I guess, I don't know. I think it should be one of the smiley faces because they're circles. Let's do laughing face. Okay, I wish I could draw those, but if I try, it'll just be a disaster. Okay, so you guys, are you ready? This is a interactive portion of the lecture. Okay, so x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. What do you think? Thumbs up or laughy face? Only 2 people? Oh, 1, 2, 3, 4, 5, 6, 7. All right. A little bit more. Come on, I want 100% participation. What have you got to lose? You might as well just take a guess. Even if you don't know, guess. Why not? All right. Yes, you guys are correct. This is an ellipse. Okay. It has the A and B are different. It's in the right format. It's equal to 1. It's all good. Okay. So here's another one. B. X squared over 4 plus y squared over 4 equal to 1. Circle or ellipse? All right. Okay. All right. Better. Okay, good. So yes, this is definitely a circle because the A and the B are the same. Okay. They're the same in the denominator. All right, here we go. Here's C. And I want to point out, oh, here, your center, we might as well just make sure we see the center is in this one, 1, -2, and then A is 2, B is 3. Okay, I just want to, it's kind of good to practice that as we go through these. So for this one, my center would be right at the origin, and my radius would be 2. It's the square root of 4. Okay. All right. Here's another one. X minus 10 squared over 10 plus y plus 1 squared over 7 equal to 1. What do you guys think? I want 100% participation. Thumbs up for ellipse or laughing face for circle. And I will tell you it's one of those. All right, a lot of thumbs up. Okay, good. This is an ellipse. And we know this because it's in the format. So our center is 10, -1. Now the A is not a perfect square, but that's okay. It's just square root of 10. And B is square root of 7. It just so happens that those vertices are going to be a distance away from the center that are not a whole number, which can happen. Okay, it's fine. All right, here we go. Next one. X squared plus y minus 8 squared equal to 25. Circle or ellipse? Okay, some circles. Muhammad, why are you clapping? That's not an option. Are you supporting everybody in their choices?
I can't find the laughing emoji.
Oh, okay, that's your laughing face. Okay, that's good to know. Thank you. All right, so, all right, sweet. Yes, this is a circle. Okay, it is, I gave you this other format up here where you have something squared. Okay, so my center would be 0 because there's x minus 0 is just x squared, x minus 0 squared. And then the y is 8. And then what's my radius here? 5. Okay, it's a square root of 25, which is 5. Any questions so far? All right, now it's going to get tougher. Ready? 4 times x minus 2 squared plus 25 times y plus 2 squared is equal to 100. Ellipse is thumbs up, or circle is laughing face. People are not sure. It's a mixture. I like it. Okay, the first question is this in the standard format? All right, so let's go back and look. Standard format of an ellipse is in the green up here, or the blue. Okay, notice that it's divided by stuff and there's no number in the front. Do you guys see this? There's no number there, and it's equal to 1. In the circle, it's the same except the same numbers in the division part. We don't have either one of that. So actually what we have to do here is we have to do a little bit of work. I want a 1 here. Must be 1. So let's divide everything by 100. So 4 times x minus 2 squared over 100 plus 25 over y plus 2 squared over 100 is equal to 100 divided by 100, which is my 1. That's what I want. Okay. Someone put something in the chat. Let me look. Yeah. All right. So 4 over 100. Now, if I simplify these, 400ths is really, I hope you see that this is over 25, right? 4 over 100 is 4 over 4 times 25. That's 1 over 25. Plus y plus 2 squared is going to be over 4, and this is equal to 1. Okay, so it was not immediately obvious, but just like one little thing we did, just by dividing by 100 on both sides, I quite easily got it into that ellipse format, right? So now those of you that guessed ellipse, you were correct. And my center is 2, -2, A is 5, and B is 2. Okay, any questions on that? All right, let's try one more. 2 times x plus 4 squared plus 2 times y minus 2 squared is equal to 36. Yeah. ellipse or circle? Okay, got a couple circles, couple ellipses. People aren't quite sure. It looks like it's equal to something squared, but the problem is I have those 2's there. So let's divide everything by the 36. So 2 times x plus 2 squared over 36 plus 2 times y minus 2 squared over 36, and then 36. So I divide everything in the equation by 36. Now 2 over 36, that simplifies. Let's just make sure we understand that. That's 1 times 2 over 18 times 2. So it's 1/18. So this is x plus 2 squared over 18 plus y minus 2 squared over 18 equal to 1. So now what do you think? Oh, I wrote, oh, it should be 4. Thank you, Marianne. Now what do you guys think? Circle or ellipse? Let's re-poll it. Happy face for ellipse, or for circle, thumbs up for ellipse. It's still a mix. Okay, it looks like ellipse, but notice how the denominators are the same. Okay, that goes with more of our circle because the denominator is the same. Okay, when you have the same number down there, it's a circle because every point is going to be the same distance from the center. So my center here is -4, 2, and my radius is going to be square root of 18, which, I mean, you could simplify it. It's going to be 3 square root of 2, but that's fine. Okay, questions? So a circle is just a special ellipse where the points are all the same distance. Your A and B is the same, you get a radius. All right, now we're going to do an example where, like this, okay? So this is probably the last example I'll get through. I don't know, example 4 maybe. So let's graph x squared minus 4x plus 4y squared plus 8y minus 8 equal to 0. Yes, that's true, Marianne. Okay. Is this a circular ellipse? Nobody knows, okay? We don't know because it's not in the right format. It's not even close to being in the format I just gave it to you in, okay? It's not even close. So we have to do a lot more work than just a simple division to see if this is an ellipse or a circle and how to graph it. Okay, so here's the thing. Just like with the parabola, see how we got stuff squared? Remember when we had to complete the square to get it in vertex form? We've got to do that again to get it in ellipse or circle form, okay? Only I have 2 complete the squares to do. I have one for the x squared guys and for the y squared guys. So we are going to, so to get this, let me put a note over here. Note, to get this equation in ellipse form, we need to complete the square twice. Okay, so we're going to group the x's together and the y's and treat it as like 2 kind of separate problems we're doing at one time. So I'm going to put the x squared minus 4x together and then put a plus, and then I'm going to group my 4y squared plus my 8y, And then the lone number, I'm just going to throw off to the side. Everybody see how we did that? You put the X's together in one, the Y's, but it's still the same as like with the coefficient that's just a number. You just kick that off to the side. Okay. Now, I'm going to do all the stuff at the same time. So looking at this first one, I have a 1 in front of the x squared. So we can just kind of go right at it. So I'm going to take x squared minus 4x. And then, so I have -4. I'm going to divide that by 2 and square it. That's -2 squared, which is 4. So that's going to be +4 minus 4. Any questions there? Now for the other one, I don't have a 1 in front of the y squared, so we need to factor this out. So this is y squared plus 2y minus 8 over here. So this is going to be x squared minus 4x. I'm just going to rewrite this and bring this down. And now it's time to do this other one. So I'll do this one in blue. How's that? So now for the other one, for the y term, we're going to take the 2, because that's my middle coefficient, divide by 2, square it. So it's 1 squared, which is 1. So we're going to do +1 minus 1. So I just complete the square 2 times, just like 2 little mini complete square problems in one. Any questions? You guys all with me? This is good. All right. So then we're going to do our kickouts. So x squared minus 4x plus 4, that stays. And I'm going to kick this -4 out. And then I have +4 times y squared plus 2y plus 1. And I'm going to kick out the -1, but don't forget this -1 is being multiplied by the 4. So I got to multiply by 4. And then I still have -8. Any questions there? Okay. Yep. All right, so now this is something squared. This is x minus 2 squared plus 4 times y plus 1 squared. And then out here, I have -4 minus 4 minus 8. That's -16 is equal to 0. Any questions there? Everybody see, just rewrite x squared minus 4x plus 4 is something squared, the same thing there. Now, I'm almost there. You can see we're getting closer, but we're not quite there. So let's add the 16 to both sides. So I have x minus 2 squared plus 4 times y plus 1 squared is equal to 16. Now, if there was nothing in front of that y plus 1 squared, it would clearly be a circle, but it is not the case. So let's divide. Now we're going to divide everything by 16. Okay. And so here's our final form. X minus 2 squared over 16 plus 4/16 is 1/4. So this is y plus 1 squared over 4 equal to 1. So this is an ellipse. Okay, because the bottoms, the denominators are not the same. My center would be at 2, -1. A, the horizontal stretch is going to be 4 units and B is 2. So we were asked to graph this. So let's finish that out with a graph. Okay. So here's my center, 1, 2, down. Here's my center. And then the vertical or the horizontal stretch is 4 units. So let's see, 1, 2, 3, 4. So 1, 2, 3, 4. And I'm going to count right now. This is 6, -1, and this is -2, -1. And then my up down stretch is 1, 2, which is 1, -1, and then 1, 2, which is 1. I'm sorry, I don't know why I put 1. This should be a 2. 2. On the y, I went down 2, so this is -3. Okay, is that okay? And then my ellipse is going to look like this. Any questions? Now, this is a lot. I get that this is a lot of steps. This is as hard as they get, though, if you have to complete the square once or twice. Okay. Any questions on anything? Wouldn't the top be 2, 1? Oh yeah, I had fixed it. 2, 1, yes. Thank you. -1 plus 2 units up is 1, you're right. Okay, any questions? All right, so this is an online homework on this stuff tonight. Yep, and that's all. That's chapter 10. That's all we're doing from chapter 10. We're done. All right, you guys, have a good day. I'll see you tomorrow.
Thank you.
Bye.